Okay. Let's make this a good one for Hannah and her sisters. It's a movie. Hannah and her sisters. Anyway. Hannah's not here. Marie's not here. No, Marie's here. Marie, hey, how you doing?
I've been here for like a month, so.
It's pretty good. She's actually come a couple days in a row. Sarah's not here. All right, look here. Here's a test. Can't show it on camera. Otherwise, you might get some, I might actually watch this. Notice the lack of questions. There are just problems on it, okay? And pretty much every problem is represented up here on the review. If you can do this, this is one of those tests. I don't say this all the time, but I do say it. There are tests that I say, hey, you got to go home tonight. If you don't study this part, you're going to do lousy on half the test or a third of the test or a quarter of the test. This is not one of those tests. This is one of those tests where you don't have to study. If you pay attention and you get all these right, there's not anything different I can show you on a test, with the exception of changing the numbers. Same problem. Find a density, change the numbers. Find the mass of it, change the numbers, or change maybe the equation. But that's it. I mean, there's not much else I can do. All right, so let's see if we can do these. Go over these quickly. There's one or two of these kind of conversion ones, one or two density problems. PV equals nRT problems, probably about 2 or 3 of those, and about 2 or 3 of the stoichiometry problems. Okay, here we go. Oops, not yet. Now, the first ones are pretty short. Let's do those first. First one's a conversion. All I have to do for number 1 is 3.5 times 10 to the 24th molecules. Convert it to what? What does it ask me for? It's converting it to, well, it doesn't say specifically liters, but I hope by now you know volume is in liters. So you have molecules on the bottom, liters on the top. 6.022 times 10 to the 23rd. We've seen that number since, chapter 3 or 4. And 22.4 we just saw in this chapter. That's how many liters there are in 1 mole of a gas if it's at STP. Okay? Well, you guys did that. I'm assuming you all did that. Katie did that. What'd you get, Katie?
130.
She got 130. All right? Significant figures-wise, it looks good because there's 2 significant figures there. That's got 2. My units will be liters. There you go. Pretty easy. All right, let's do the next one. Density of neon gas at STP. You know how to do a density problem since, again, chapter 1, I think, or 2 maybe. D equals M equals V. The difference is going to be, here, it looks like I didn't give you any numbers. When we did density problems in the past, you had a mass, you had a volume. Here, you're asked to find a density, and you're not given a mass or a volume, so you use the molar mass and 22.4, the molar volume, of a gas at STP. Do be careful. I'm going to warn you about one of the mistakes. You wouldn't have made it here. Neon happens to be a simple gas. He's not diatomic, just 1 atom there. So the mass is 20.180. That's the molar mass from neon on the periodic table. If it had been chlorine or fluorine or any of the Brinkelhoff ones, times by 2 because it's a diatomic. Volume's always 22.4 liters, and there you have it. What do we do to solve the problem? Well, D equals M over V, 20.180 grams over 22.4 liters. What we get for that one here, Garrett, what'd you get? 0.901 grams per liter. Anybody else get that?
Yep.
Looks good for everybody? All right. Now, I do want to warn you about this. I'm trying to, on the review day, I'm doing it pretty quickly, but I'm also trying to point out the mistakes that I always see on the test or somewhere else I've seen throughout the worksheets. This next one's a classic. I'm doing this, I'm asking for molar mass, and I'll have people waste their time trying to do this guy as a PV equals nRT problem. See why? Isn't there a PV equals nRT problem I have to do a molar mass on? Right? And then I'll have other people who will leave the PV equals nRT problem, the ideal gas law problem, blank, because they'll think, well, you didn't give me the density. Okay? There are 2 ways I could do the molar mass. I could do it given the density, or I could do it giving you the volume and the temperature and the pressure and the mass. Okay? This is one where I clearly am giving you the density. So all you have to do is D, M, and V. This is not PV equals nRT, which some of you might have thought or will think on the test. Your D is 1.5 grams per liter. Your molar mass is the mass of 1 mole of a gas at STP, and your volume is 22.4 liters. Another problem with this, by the way, before I go and finish it, when I give you a density problem, people, I'm not going to ask you for a volume. So if you find the question asking for a volume, chances are it's not a density problem. Chances are you're going to be using PV equals nRT, the ideal gas law. All right, D equals M over V, but this time I have to rearrange it. I'm looking for M, so I will multiply both sides by V. V times D equals M. Plug my numbers in. V is 22.4 liters. D is 1.5 grams per liter. Do be careful here. There's one more thing you might do wrong here. I didn't ask you to do it in this one. It's a review day. Try to shorten them up so you get them all done in 20 minutes. I can cover them in 20 minutes. I could have changed the units. You could have milliliters here. If I do that on the test, make sure you change it to liters because this is in liters. Okay. What'd you get for that? 34 grams. Because liters cancel. Does that sound good, everybody? All right. So there's your first. I'll bet you the first 4 problems are like those. Density or conversion problems. First 4 problems. Then we get to the harder ones. The ones that are using the ideal gas law or stoichiometry. Okay, let's do this one first. Now this one says find the temperature. Gives me the moles. And it gives me the volume and the pressure. That's a classic example of a ideal gas law problem. Okay. What's my pressure? Can't use 653 torr, even though that is the pressure. I have to convert it to atmospheres. 1 atmosphere contains 760 torr. 760 is not going to limit my significant figures. We know that. What'd you get for that conversion, Spencer?
0.859 atmospheres.
0.859 atmospheres. Okay. My volume. What'd you get for the volume here? Look at that, 89.4 liters. He's already converted for us. Don't have anything to do with him. He's easy. 89.4. My moles. I'm told I have 2.89 moles. Hey, do be careful here. I'm pretty sure on the test I have one where, what if I had said instead of 2.89 moles, I had said you had 28.7 grams of chlorine gas. You would have had to have converted it to moles, right? And you know how to do that. R, by now, you better know it. You know, I told you this before. I think I told you to be surprised how much of the periodic table you would know by the time you get to the end of this year. This is another one of those things. I never told you to memorize this number, but there's no one in here who doesn't know it's 0.0821 by now, just from doing the problems, okay? Temperature, again, by now you know how to add 273 onto something, and you know, in this case, you don't know. But if I ask you to do a conversion temperature, 273 and 760, they're kind of stuck in your head already from having done it so much. All right, I'm looking for T. Let's do the equation. PV equals nRT. Divide both sides by nR. I hope you see why. You're solving for T. So T equals PV over nR, which equals 0.859 atmospheres times 89.4 liters over 2.89 moles times 0.0821 liter atmospheres per mole Kelvin. Do all of that on your calculator, and here's another reminder of something you might do wrong if you don't get this answer, but you have these numbers here. Well, first of all, it's only 1 point off. That's nice, because I'm such a nice guy. Don't tell anybody. But basically, if your math mistake is just a math mistake, that's it. You have everything else set up here, which many of you still don't do on your homework, and you don't mind losing a point or so for that. But on the test, not so much. On the test, if you don't show me this equation rearranged, you remember on the homework, I don't grade for correctness. So you don't show me this equation rearranged, you don't have all the numbers plugged into the side, and you don't do all of this. And I can't tell where your mistake is. I'm not just taking off 1 point, even though it was a calculator error. I won't know it was a calculator error. So you're taking your chances, whereas you could have lost 1 point, you might lose 10 because you didn't show me the work. So just keep that in mind. Some of you in the homework are still, taking liberties and not costing you that much. It'll cost you a lot more on the test. Okay, if you do this, like I was telling you about the math, this times this, divided by that will give you the right answer. Because your calculator doesn't know. You try to divide by this times that, unless you use parentheses. You can do that, or you can do them separately. But the easiest way, really, is just go this times this, divided by that, and you will get the right answer every time. Which is what, Brendan? What'd you get?
323.7 Kelvin.
324 then?
Yep.
Is that correct? Okay, and that's Kelvin. Hey, what if I asked you for that in Celsius? What would you then do with that number? Subtract 273. Okay. Let's do another one. We only have 2 more left. This one is what kind of a, oh, by the way, you know, I also found, I just realized this, I'm going over this, I realized that there are people who don't realize when it's a stoichiometry problem. And they'll be trying to do a problem that's just a PV equals nRT as a stoichiometry problem, and vice versa. Trying to do a stoichiometry problem as a PV equals nRT problem, an ideal gas law problem. All right. Basically, I can tell whether something's a stoichiometry problem if it's talking about a reaction. Some guy reacting with somebody else, something decomposing into something else. Is there a reaction here? No. So this is still just a PV equals nRT problem, but it's a harder one. Because it's asking you to solve for, and this one's asking you to solve for mass. When I put this one in here, I'm going to show you what I might have asked you to solve for, and will, I know, on the test, ask you to solve for as well. Okay? All right, P is 3.50 atmospheres. V is a 10.0 liter tank. And we're going to leave blank for a second. 0.0821 liter atmospheres per mole Kelvin. And T is 300 Kelvin. Now, that N, I can, although in this case I'm not going to, but I can break down into mass over molar mass. Did anybody solve it that way? Anybody solve it that way? One person only? You don't have to. You certainly don't have to. Don't change it, okay, if you didn't. Okay, but the reason I'm pointing this out to you now, because I did not have time. I don't have time to do one of every type of problem when there's only 20 minutes to go over them. What if I asked you for the molar mass of the gas and I gave you the mass? You all know I can do that and will do that on a test. You would plug this into the equation instead of N, right? Y'all remember that, doing one like that. If you don't, look it up. Don't write this down, but this is what it would look like. You'd be using that and solving for molar mass. I would recommend if you have it. So one thing I could say you could screw up on this test, all right, because I didn't really go over it directly on the review. All right, but this one does not ask me. I could actually don't have to do that here, as you'll see. I could just solve this guy for N. Well, that's not what it asked me for. It asked me for mass. No biggie. When I get my moles, what can I do? I can convert it, right. So let's do a problem. PV equals nRT. I'm solving for N, so I'll divide both sides by RT. N equals PV over RT, which equals 3.50 atmospheres over, times 10.0 liters over 0.0821 liter atmospheres per mole Kelvin. You know how tired of getting right in that? If you guys think you've done it a lot, I've done it more. 300 Kelvin. What'd you get for your N, the moles? Not the final answer, but just moles in this case. Jackson. 1.42. He got 1.42 moles. Anybody else get that? Yep. What do I do with that? I convert moles to grams. 1 mole contains, it's chlorine gas. Got to remember he's diatomic. 70.9. What is it? 906. 906. Okay. And do the math, and you get what, Brandon?
100.7.
101 then? Yep. Significant figures. That good? All right, one more I'm going to do. Running out of voice here. All right. This last one is one of at least 2 you'll see on the test, maybe more, that are going to be stoichiometry problems. Now, we have just enough time to go over this slowly and also hint at the other kind. Remember, can't do every single type on the test, but this will certainly, 90% of this problem is the same as the ones that are not an STP, right? So we'll talk about that right now. But I need your read. Okay. I am going to look each time for some different information. The first time I look up there, I'm looking for the equation, like any stoichiometry problem. Lithium hydroxide is being decomposed. Decomposition of lithium hydroxide. I'm going to leave out the words just to save myself a little bit of time. LiOH yields. What does lithium hydroxide break up into?
Lithium oxide and water.
Lithium oxide plus water. And that's exactly what people will do. You did it in the lab yesterday. Multiple people had the wrong equation because they didn't look the charges up. If you have LiO, you're wrong because you didn't look up +1 - 2 Li2O, right? And then you have to balance it. 2 there. Anything else?
No.
You sure? I mean, it looks like I got, oh, yeah, there's an O here and an O there. There's 2 O's anyway. See, 2 O's, good. All right. Now, that's your first step. You screw up there, it's obviously going to carry on later on, but it doesn't mean you just leave it blank. I won't punish you twice for the same mistake. If you screw this up, you'll lose points. Not a small amount of points, not just 1 point, it's points for that. But if you do the rest of it correctly based on what you have up there, you're not going to lose points for these conversions. All right, so what do I look up? The second time I look up, I got that. 1.34 grams of lithium hydroxide starts my conversion. I want to write small, 1.34 grams LiOH. Beginning my conversions. What's going to go on the bottom? Well, I know my goal in stoichiometry by now, I hope you all know, especially after the lab just yesterday. By now you know the goal is moles to moles. I want to get my mole out of my moles that I have and into the moles that I want. So I'm not in moles, I'm in grams. So I write lithium grams on the bottom and moles on the top, and I convert my grams to moles for lithium hydroxide. Now, to do that, I got to add up 1 Li, 1 O, and 1 H from the periodic table. What do you get when you add those up? What's the molar mass of those guys, Rupesh?
I didn't get that yet.
Who? Anybody get that one? Michael?
23.9 grams.
23.948 grams. Okay. All right, and your moles, of course, are 1. Either way. No. Good mistake. See, you're making fun of Brandon for this.
That wasn't a mistake.
Oh, it is a mistake.
I purposely did that.
That's wrong. That's absolutely wrong.
That's absolutely my calculation said I knocked off the 3 because there's a 3.
But see, that's wrong. You can't do that. You do not round off before the multiplication or division. You round off after, as Brendan well knows and is schooling you right now. Anyway, look at the fact is, the reason that would still be 23.948 is because the numbers you were using from the periodic table did have like 5 or whatever significant figures. Okay. All right, let's keep going here. We're not going to get off on a tangent here. All right, my moles. I'm in moles of lithium hydroxide now, so I have to do my actual stoichiometry step. Moles of what I have. I read back one more time. Who am I looking for? I'm looking for water. So I put moles of water on the top. Well, how do I know? Is it always 1 next to moles? I thought I said it was always 1 next to moles. It is, except in stoichiometry where you use the coefficients.
2.
You use the coefficients, right? In the stoichiometry step. Good. All right.
Keep going.
I'm running out of breath here. This is really...
Do you want me to take over?
You could, I'm sure.
I could.
Marie Wizard Spooch Daddy could definitely do this.
I could do it.
Moles of H2O.
Hi, Anna. Everybody say hi to Hannah. Hi, Anna.
Think
Yeah.
she's sick?
I don't know. We're just saying hi to Hannah. She's not here. We know she's going to be watching. So, all right. Okay, what am I looking at now? I go from moles to what I have to moles to what I'm looking for. What goes on the bottom? Moles of what? Water. And on the top? Big mistake there by Brandon. Now, Mike, you got to jump on him.
You suck.
I don't mean literally. Get off him. Mike, get off him! For Hannah's thinking she can't see. Jump on him. I mean, you know. Anyway, no, we could have asked for grams, but I didn't. I asked for liters. By the way, I'm about to stop right here. Everything up to this point is exactly the same. If this had not said STP, if it had said it some pressure and temperature, everything up to right here is exactly the same. But I can't use 22.4. I would have to skip this step and do what at this point? PV equals nRT. Right. I'd have to do the ideal gas law where your moles would be your answer to whatever you get here because you wouldn't be doing this step. But, of course, this guy is an STP, which makes life a little bit easier. I multiply all that out. I divide it all out. What do I get for my final answer? A number. Very good, Brendan. What number do we get?
Greater than 1.
0.627?
Yeah.
0.627. And that's in liters, right? Is that good?
Making sure Hannah's on her toes.
Hannah is good to go.